Okay, we're ready to begin our tech talk today on Teamcenter Requirements Management Part 2. Now, questions will be answered live at the end, but go ahead and enter them into the chat as they come up. Our presenter today is Sandeep, who is located in our Cincinnati office. And here's a little bit about Sandeep. He's an application engineer with extensive experience in Teamcenter, building creative solutions and providing superior technical support for our customers. Sandeep, the tech talk is now yours.
Hello everyone, welcome to Prolim Tech Talks. I'm Sandeep Kumar Bolapalli, a Team Center expert here at Prolim. Today's topic is Team Center Requirements Management Part 2. In our last session on Team Center Requirements Management Part 1, I explained what requirements management is and how it helps in product development. I covered how to create requirements in different ways, either by manually or importing them or by using predefined templates. I explain how to edit requirements, attach supplier data, add images or other files, giving secured access, analyzing the quality of requirements, and also explain how to work with requirements management workspace. Today in part 2, we will go a step further. First, we will look at trace links which let us connect requirements to design elements so we can see exactly how each requirement is being implemented. Next, we will learn how to apply workflows to requirements so the review and approval process is well structured. We'll also see how to validate product compliance with the requirements, making sure what we build meet the original goals. By the end, you will have a clear understanding of how these features help in tracking, managing, and verifying requirements in Teamcenter. We'll wrap up with some key takeaways and then move to the QA session. So, trace links in the context of requirement management refer to the connections or relationships established between different objects such as requirements, parts, or other items within a product development process. So these links are crucial for maintaining traceability, which is the ability to track and understand the relationships between the objects throughout the development lifecycle process. Now let's see how to create trace links between requirements and design parts and also see what happens when the design is revised and what the existing trace link do. Let's log into Teamcenter. This is how my Teamcenter homepage looks like. Let's go to the Explorer, the place where it displays all the files. And here is the example of requirements that I have created. You'll see the tree structure of requirements. I explained how to create, add data, and all the requirement description in part 1 Teamcenter requirements management. So at this moment you see to the right in the window the requirement has been described: performance, compliance, horsepower, and also with some payload, etc. So right now we are going to link the requirements to the design part. So right away you can see the icon here, or you can do alt key with L button. This now gives you a small window for creating a trace link. It already added the engine system requirement in the start section. So this is a defining object. The engine system, which is added in the start section, is a defining object, which means it creates the rules where the complying object, which is going to be added in the end section, has to follow. So let's go ahead and add the design part here. Since I know the exact part or the assembly which is going to implement this requirement, I'm going to search for the part using the advanced search. Add, and you can select the type of link. I'm going with the default trace link and say create. So this now creates the trace link. You see 89 has been added to the requirement, and when you say more, you'll see list of all existing trace links. So the first two are related to a test use case where we are going to perform a validation at the end of the session. So this is like a high level overview of creating a trace link. Let's add some more trace links to the other requirements. I'm going to add some traces for the safety features as well. And you can also add more. Let's say add. Well, this looks good for me. I'm going to say create. Now the link has been updated, and you will see all four defining objects. So what happens when a part or design is revised? Will the requirements look at the new revised part or the old part? So it is up to the organization to configure these settings. Requirements can look at the old specific revision, or requirements can also look at both old and new revisions. So right now, if you see this requirement is pointing to a part engine system on revision A. What happens when this engine system has been revised to B level? Let's open the part and revise it to B level. I'm going to B, revise, and save. So going back to the requirements now, let's refresh the window. And if you hover over on this trace link, say more, and you will see both A and B revision has been added to the same requirement. Going back to the presentation, that's how the trace links establish the traceability among different objects, in which one object takes precedence over the other. So in the context of requirements management, a trace link matrix is a table or a grid that displays the relationships between requirements, which allows users to track and analyze the connections between them. It enables users to create trace links between requirements, system models, and many other objects. It provides a clear understanding of how requirements are related and how they impact each other. So the tracelink matrix is used to establish traceability, analyzing the requirements, identifying gaps, inconsistencies, and redundancies in requirements, managing the complexity. It visualizes the relationships between requirements and the system models, making it easier to manage complex systems and ensure that all requirements are met. Now let's see how to create a tracelink matrix in Teamcenter. So back to the requirements, and here I should be able to generate a tracelink matrix, and this will give me a small window to configure some settings. And I have an ability to switch between various types of matrix. I'm going for a easy quick matrix, and I'm not going to show the parameters here. By default, it picks the same object in both row and column. If you generate the matrix, there will be no links because we have no internal links. Going back to the matrix generation wizard, you can always replace the column. I'm going to replace this with the assembly structure and replace. Now generate the trace link matrix. So now you will see all existing links indicated as 1 here, and if you click on this one, this will explain you which is the defining object and what is the complying object and trace link type, etc. Not only this, you can also create a trace link right away. Let's say engine system, you would like to add it with the body. Double click and this will give you a trace link window with adding both defining and complying object, and say create. So instead of going to each and every object and checking for a trace link, trace link matrix gives you a good view of which object has been linked to which requirement or which design. So it basically visualizes the relationships between requirements and system models or other objects, making it easier to manage complex systems and ensures all requirements are met. So that's all about the trace link matrix. It helps saving time looking for the trace links. So next I'm going to discuss about suspect links in Teamcenter. Trace links connect different objects like requirements and system models, and these objects often change during the product lifecycle. So when one object changes, the people who own related objects need to be informed so they can review those changes. So this is where suspect links comes in. For example, if a requirement is linked to a system model and the requirement is updated, Teamcenter will send a notification to the system model owner. This way, they know something changed and can check if it's affected their work. Also, only checked in objects can send notifications, and objects that are released or denied access won't send these alerts. So, when a requirement changes, the system automatically starts a workflow that notifies the related owner. They get the message in their inbox with a report showing what changed, and the owner can then add comments and either approve or reject the change. So this system helps keep everyone informed about important changes and makes sure that linked objects stay consistent throughout the product's development. Now let's see the suspect link sending a notification inside Teamcenter. Back to the requirements. Hover over on any trace link to see if there's any existing designs. So it has three designs, 452, 97 and 98. Let's make some changes here. Instead of 500 kg, I'm going for 700 kg and going to save. And now I'm going to mark this as a suspect. And I can enter the comments. You can also set the due date for the design owner to review it. Going for 30 days and marking as a suspect. So now let's see who is the owner of the design part. Let's open 452 and see who is the owner. 452 is owned by Ed, is under engineering group. Let's log into Teamcenter as Ed and see if he is notified. So we are in the home page of Ed's Teamcenter and you will see the notification already popped up. And it is asking to review the suspect. And it has all the task instructions assigned to Ed, and it gives the targets. 452 is the design part and this is the requirement, and a compare report PDF, which is what we are watching at the right side. And you will also see the highlighted text which has been changed. So at this moment, as a designer, I can either reject or approve. And if you go to the workflow, you'll see the map of the process. This is a pretty small workflow which asks the designer to approve or reject the new changes. Going back to the overview, and as a designer, I'm going to say approved for 700 kgs. So this is how a suspect link notifies the designer or the user who owns the object automatically. It uses dispatchers behind Teamcenter for this automatic process. So when a requirement changes, the system automatically starts a workflow that notifies the related owner. They see a message in their inbox with a report showing what changed. So the owner can then add the comments and either approve or reject the change. So this is how the system helps keep everyone informed about the important changes and make sure that linked objects stay consistent throughout the product's development. Submitting requirements to a workflow is really important because it helps us manage the whole process of handling those requirements. When a requirement goes into a workflow, it follows a path like who needs to review it, approve it, or maybe make changes. So this way, nothing gets missed or approved by mistake. It keeps everything organized and makes sure the requirements are checked by the right people. It also helps maintain quality and consistency so the product is built the right way. So using workflows for requirements makes the whole process smoother, clearer, and more reliable. This is nothing new. This is the same way as you execute workflows on the regular parts designs. Similarly, we are going to perform the same workflow process on requirements as well. Now let's see applying workflows on requirements. So now let's see how to create a parameters for a specific requirement. Considering infotainment system, you can see the parameters already defined using the show parameters option. And there's a parameter which is already created. It says infotainment rating and minimum and maximum of 1 to 10 scale. And you have a freedom to create more parameters. I'm going to create a new parameter called bass level, and it is a string type. Goal is 30, minimum 1, maximum 40. Add. So the final end product can be tested against these parameters defined on the requirements. You can record the manual results and add it to the test cases, and where you can pass and fail the test case, and that's where the validation process goes on. I'll show you at the end of the session. So you can add as many as requirements for any specific requirement. So after creating requirements, adding relevant information, creating trace links, and also adding parameters. Once the requirements are in a stable stage, you can release the requirements. Right now, I'm going to select all the requirements which are in a good stage to release. I'm going to say submit to workflow. I selected Prolim release as the workflow, and you'll see all requirements in the targets and say submit. Going to the detail section in order to access the workflow section. And this is a pretty small straightforward workflow, and it has a small review task, and it assigns the flag on every requirement. So currently we are at this stage of reviewing the task. If you expand the task, we are at a stage to select the team for the reviewer. I'm going to select myself as a reviewer. And this will again revert back to me since I'm logged in as Prolim. Assuming I checked all the requirements here and it looks good for me, and I'm going to approve the requirements to be released. So now the workflow has been completed, and you will be seeing the release status on each single requirement. So this is how a requirement goes into a workflow. It follows a path, and users review it, approve it, and maybe you can also make changes in between the workflow. So this way it helps you, nothing gets missed or approved by mistake. It keeps everything organized and make sure the requirements are checked by the right people. So using workflows for requirements make the whole process smoother, clear, and more reliable. Validating product compliance with requirements. Requirements and test cases work hand in hand to make sure the product meets what's been specified. First, requirements are captured and managed in one place, so everyone has a single source of truth. Then, each requirement is linked to one or more test cases. This link creates traceability so we know which requirements are covered by tests and which still need them. Something we can easily check on the test coverage. Test cases can be created anywhere directly from requirements also, and tracked in a centralized interface. Once ready, they are executed to verify and validate that the product actually meets the requirements. Together, they ensure the product meets its intended purpose and quality standards. For compliance, test cases provide a great interface that guides us thorough validating requirements. They clearly show which requirement we are testing, the related test case, and the parameters to check. When we execute a test, the system asks us to confirm if the requirement has been met based on these parameters. So the structured approach makes it easy to track results, link them directly to requirements, and see the compliance status at a glance. If something fails, it's immediately visible and know exactly which requirement needs attention. This way, test cases act as both the checklist and the proof that all requirements have been properly validated for compliance. Now let's see the validation in Teamcenter. Back to the Teamcenter. This is an example of a test case that has been created to validate our requirements and design parts. You can also create parameters on test cases, not only on requirements, you can also create parameters on the test cases. All the parameters defined on requirements and also on test cases can be validated in the validation step. So we have test case created, and let's open the actual test object where we are going to add all the requirements, test cases and parameters, and we'll do the manual validation process. So let's open the test object. So this is the main test object where we are going to perform the validation, the testing. So you see the requirements have been already added. We're going to add the test case that we created, and you can also add the parameters as well. So here at this point, I'm going to search for the test case that I have created. Say add. Expand the test case. So right now I'm going to validate requirements and the test cases. I'll show you validating parameters down the road. So you have created a test object, adding the requirements, test cases, and parameters. And now this test object has been assigned to a tester on the manufacturing floor. So as a tester, I open the test object and I can preview the requirements. And also I can preview the test cases. So as a tester, now I check the end product and validate it with the requirements, whether it has been designed and manufactured following the standards, and add the results accordingly. I'm going to say it passed the requirement. Similarly, I checked all engine system, infotainment system. All looks good. It followed the standard steps mentioned in the requirement. And now I'm going to start the test cases. If I check the preview, I have the steps to perform. Assuming I performed all the test cases and the results are good, I'm going to pass these test cases as well. Since all the requirements and test cases are passed, I'm going to pass this test object as well. Overall result is pass. Execution completed. I'll show you a small video where I perform parameter validation as well. This is another test object where I added requirements, filter based on failed and passed requirements. I also validated test cases using steps provided in preview, and also validated parameters defined in test cases and requirements manually on the end product, and added the results. Going back to the presentation, with this setup, we are not just running the test cases, we are also validating the requirements and checking the key parameters. This ensures that every feature we test directly ties back to a requirement and that the parameters meet the expected values. In the end, it gives us full traceability and confidence that the product is functioning exactly as intended. To wrap up, we have seen how trace links form the backbone of requirement traceability, connecting everything from design parts to system models. The tracelink matrix gave us a visual tool to manage and analyze these relationships more effectively. When things change, suspect links ensure that the right people are notified, preventing surprises downstream. By applying workflows, we make sure that requirements are reviewed, approved, and tracked in a structured, reliable manner. Finally, linking test cases to requirements allows us to verify and validate compliance, ensuring that our product meets both expectations and standards. Altogether, this setup provides robust traceability, enhances product quality, and builds trust in the development process.